of symmetry. And one that we're probably a little more familiar with is line symmetry. Okay, determining whether a figure has line symmetry is essentially just seeing if I can draw a line through the figure somewhere, and if I fold my paper over that line, the figure or the two halves sit on top of themselves. So, for example, right here, I can draw one line down the middle of this heart. If I were to fold my paper over that line, those two halves would sit perfectly on top of each other. So we say this heart has one line of symmetry. Okay? There's no other way that I can draw a line through this heart to where if I folded over that line, the two pieces would sit on top of each other. Okay? So, I mean, this is something you guys have done before. There's not a whole lot of explanation for line symmetry, but we are going to practice this a little bit because there are some figures that are trickier to see lines of symmetry than others. Okay, now, not only do we want to determine if yes or no, if there is line symmetry, we want to see how many lines of symmetry each of these figures has. Okay, so let's take a minute here, okay, and see if we can determine, okay, first, whether these figures have line symmetry or not, meaning I can draw a line through the figure, and if I fold over that line, the two halves are exactly the same, and then how many lines of symmetry. Okay? So I will give you a hint, I guess. For the ones that do have line symmetry, there are more than one line of symmetry in these examples. Okay? Some of them may not have any symmetry at all, but for the ones that do have line symmetry, there's more than one line of symmetry. All right, so let's take a couple of minutes and see what we can come up with here. So don't jump ahead yet because the back's a little bit different. We're doing rotational symmetry on the back instead of line symmetry. All right, so let's talk about these figures here. Okay, I'm seeing a lot of correct answers as I'm walking around, but maybe a few discrepancies. So on number one, how many lines of symmetry did we come up with?
5.
I think there's 5. Okay, I think pretty much everybody saw that line right there, right down the middle. Right, but I can actually draw that same line 5 different times essentially. Okay, I can draw a line from this corner to the middle of the opposite side. I can draw a line from this corner to the middle of the opposite side. And I can do that for every corner, from the corner to the middle of the opposite side. If you rotate your paper, it might be a little bit easier to see. Okay, if you rotate your paper to make this point the top, then you can see, well, those two halves are exactly the same. If you rotate this corner to the top, it might be easier to see that we actually have 5 different lines of symmetry here. Okay? So I guess to write out our answer, we would say yes, it has line symmetry. There are 5 lines of symmetry. Number 2, I think, was the one I saw the most discrepancy as I was walking around. So how many lines of symmetry did we come up with for this flag here?
Or I could have sworn it was 6.
So I'm hearing 2, 4, and 6. Okay, so I think the 2 that probably everybody agrees on are this one here and this one here, right?
I mean, yeah.
We can all see that those 2 would be lines of symmetry. Now, I'm assuming that some people said, or the ones that said there are 4 lines of symmetry said that we could do diagonal, right? So if we think about these diagonals, if I were to fold over this diagonal, do the corners match up? They don't, right? If I took this corner and folded it over this line, this corner would end up here somewhere. And this corner would end up down here somewhere, right? So if you don't believe me, physically do that with your paper, right? Take your paper and fold it over a diagonal line that you drew, okay? The figures won't match up. So the diagonal lines are actually not lines of symmetry here. Right? Kodak, I'm curious. Where'd you come up with 2 more?
No, wait a minute. I'm done.
Okay. All right.
I'm done.
Alright, so I think on this one, we actually only end up with 2 lines of symmetry. Okay, so this, you would say, yes, there are 2 lines of symmetry. How about number 3? Okay, this one was probably the other one that had some discrepancy. Okay, a lot of people said 0, but then some people, had maybe a line drawn right through the middle here. Okay. It kind of looks like, if I fold that over, it might match up. Okay, but it doesn't. Maybe a good way of determining is if we think about our rule for a reflection. Our rule for a reflection was, well, if I take a point, find the distance to the line of reflection, and then go that same distance on the other side, there should be a point there. There's not. Right? I could do that for a bunch of points, right? I could pick a point over here and say, well, I'm going to go that distance to the line of reflection, go that same distance on the other side. If they matched up, there should be a point there, but there's not. Okay? So, this mold Z does not have any lines of reflection. How about the last one? No, right? This one is pretty easy to see. There aren't any lines of reflection in that one. Okay? So questions on finding lines of symmetry? All right, let's flip over to the back. So on the back, we're going to talk about a different type of symmetry. Okay, so I think line symmetry is the one you're more familiar with. On the back, we're going to look at rotational symmetry. Okay? Rotational symmetry just means if I can rotate an object and it looks exactly the same as what we started with. Okay? So if I take a look at this figure here, okay, it's like a square with the corners cut out of it. We want to think about, well, if I put my finger right in the middle and I rotate it, can I make it look exactly the same as what we started with before I turn it all the way around? Right? So in this example, okay, we would say, yes, I can actually make it look the same if I turn, say, this corner over to here, right? Or this corner up to here. Essentially what we're looking for is the same number, or the same object around the outside, and we want to see how many of those objects occur. So if we're thinking about these little protruding rectangles are the same object around the edge, okay, we can say, well, that happens 4 times. So we want to determine not only yes or no, does it have rotational symmetry, but the order and the magnitude. Okay? So the order is the number of times a figure can map onto itself when we rotate it. Okay? That's the order. So here, for this figure, we would say we could do that 4 times, right? Because it has these same 4 things around the edge. So if I rotate it 4 different times, I'll get it to map on top of itself. To find the magnitude then, we just take 360 degrees divided by the order. So for this problem, I would say, well, the magnitude is 360 divided by the order of 4. So the magnitude is 90 degrees. We say this figure has 90-degree rotational symmetry. Okay, because I can rotate it 4 times before I get all the way back around to where it maps onto itself. Okay. Questions on that? Alright, so for ones like this, okay, we want 2 things. We want the order and magnitude. So order is how many times I can rotate it so that it sits on top of itself. And the magnitude is that degree measure. Right? So let's take a couple of minutes and take a look at these ones. Okay? Figure out the order. Okay, so how many times an object can rotate so that it sits on top of itself before we get all the way back around. And then take 360, divided by the order for each of these problems. Well, so how many of the same thing? So, essentially, rotate gears. So, our order is
Four, six, because this way, this way.
You're thinking more in terms of line symmetry. What we want to think about is rotating. So like, if I just rotate from here to here, it looks exactly the same. Right? And then again, if I rotate from here to here, it looks exactly the same. So since there are those things around the sides,
I don't believe it. I think you're doing pretty good.
so
You're doing good. What, 45? Are you getting your Christmas list over there? No. You're so funny. I did a ton of Christmas shopping this weekend.
My grandma was like, she was working, and she was like, so you got
no ladder.
I spent like, at Kohl's, if you spent like $50, I got $10 Kohl's cash. So I got $50 of Kohl's cash, 15 in rewards, and I have a gift card. I'm gonna go to Kohl's this weekend and do like more. I want to be done by like the first week of December.
The parents usually have it done like 3 months before Christmas.
But when you split out,
Yeah. My cousin's been shipping her stuff for her kids in my house so that I can hide it.
yeah, that's what my
Parents are so sneaky.
she was like, she would ship it to like my grandma and my aunts, and I'm like,
It ruins the surprise.
My brother found a receipt.
They're just really good at it.
Hey, bro, I bet your dad about killed it.
I thought you got
Did your dad figure out he found the receipt?
No, my
Okay.
brother found a
I
receipt.
was just saying, 'cause if your dad figured out,
Picture of the whole list and sent it to me. I was very upset.
he was not upset. He was more than happy with everything he got.
Well, you know, the whole one of Christmas is a surprise. Well, of course, spending time with the family, free food, so, you know.
Don't let the front fool you.
She used to hide it in the basement He still does. I know.
We're just saying, well, if I rotate this from five here,
For you, I'd be just like this.
so since you're it's just like
I do.
I think this one.
This
This one might.
upside down.
I'm not sure about this. I don't think this one.
I need to
But I
do
think this one might. I think it could go one time onto itself.
There you go.
That's line symmetry. What about rotational? See, like if you spin it,
No, but like L.
Oh, I haven't seen it.
I feel like it doesn't rotate onto itself until. I don't think it's not for rotational. I don't think, but I could be wrong.
I'm gonna need you to. Yep, I'm wrong. We're at. Oh, I haven't seen that happen. My grandma, since Hallmark released her movie around Christmas movies.
Well, so think about
The string is cut off.
And then when you press the back, it moves around. See?
So the big cups, there's a tiny
No, my grandma got it. Got me a bigger one.
small
I was like, Grandma, what am I gonna do? And you
So if you want to spike them, let's noisy dough. Sorry, I was noisy one was pretty cool thing. Yeah, noisy one.
Oh, I'm scratching right now. It's cheap paper too, which I have not
Oh,
sold.
you're talking about ambush.
When you get your master.
That rusted the wall.
So when you guys split it between 3, you get your master. But then you add on to it, you get your master. Well, because I have my teaching free, but you make more money if you get your master.
No offense, Miss Graham. What do you got? Like, what goes through your head thinking, oh, hey, I want to be a teacher?
I like teaching. I like kids.
I know. That's probably a good explanation.
Alright, let's talk about these here. So it seems like, as I was walking around, a lot of people were still trying to think about these in terms of lines of symmetry instead of rotational symmetry. So essentially what we're doing is just sticking our finger in the middle of the figure and turning it and seeing if we can get it to look exactly the same as what we started with. Okay, so if I put my finger in the middle and I turn it, I would just need to get this point to here for those figures to look exactly the same. Right? Or I can get this point all the way up to here to get the figures to look exactly the same. Since there are 8 of these little identical triangles around the edge here, that means that I could do this 8 times before I get all the way around to make it look exactly the same. So that means the order is 8. Then the magnitude, okay, I would just take 360 divided by the order and get that the magnitude is 45 degrees. Now for number 2, okay, again, think about sticking your finger right in the middle of the figure and turning it, okay, rotating it all the way around. Put that away from me. Right? If I stick my finger in the middle and turn it all the way around, will it ever look exactly the same before I get back to where I started? Right, we'd have to go all the way around. So if we would have to go all the way around, we would say, no, it doesn't have rotational symmetry. Okay. How about for number 3? It does. Right? If I stick my finger in the middle and I rotate it
180.
180, right? If I flip it upside down, it'll look exactly the same. So what that means is the order, okay, would just be 2. Right? There's only one way, one turn, bless you, that I can flip this to make it look exactly the same, which means the magnitude would be 360 divided by 2, which is 180. How about the last one?
No.
Right? If I put my finger right in the middle and turn this triangle, it'll never look exactly the same until I get all the way back to where I started. Okay? Questions on symmetry? Okay, so the only thing that I think can trip us up is making sure that we're distinguishing between line and rotation. Right? Line is when we're drawing a line through the figure. We can fold it on top of itself. Rotational is when we're sticking our finger in the middle and turning and seeing if we get back to where we start. All right? Questions? So there aren't lines. Okay, so we're talking about rotational symmetry. So what we're saying is if I stick my finger in the middle and I turn it, does it ever look exactly the same? And for this one, it actually turns out if I flip it exactly upside down, if I turn it 180 degrees, it'll look exactly the same. So that's a good question. If I wanted to talk about line symmetry, this thing doesn't have any line symmetry. Right? There's no way for me to draw a line through it to where I fold over that line and it looks exactly the same.
top two does.
But yeah, but the top two would both have line symmetry. Yeah, right. There's a bunch of lines that we could draw through this first one, and I think there's just one line that I could draw through this one. Right. So we could say this one does have line symmetry, but it does not have rotational symmetry. Okay. This one would have both line symmetry and rotational. This one would just have rotational but not line symmetry. And this last one would have neither line nor rotational symmetry. Okay. Other questions?